All right, so we're talking about quadratic models in section 2.6, and we need to do a lot of reminding about different things about quadratic functions in there, and specifically when we're trying to match them up to data. There's all kinds of different things you need to remember. First of all, a parabola can either open up or down, and of course we are thinking about the variety that looks like this. You can actually switch X and Y, and then you can have one that opens left and right. But we're going to stick to the up and down for what we're doing in this particular section. The parabola, let's suppose it looks like this, and it opens up. I realize that mine doesn't look as balanced as it should, but I hope you can get over that. The point where it changes directions, in this case at the bottom, or if it was opening down, it would change directions at the top, is called the vertex. And there's another line that goes through the middle. It's kind of an imaginary line, but we call that the axis of symmetry. Symmetry. Okay, and we know how to find the axis of symmetry. X is equal to, right, because we know every vertical line in the universe is always x equal, the opposite of b over 2a. That is the middle of the parabola. Now, this thing right here is called an x-intercept. It's where the parabola crosses the x-axis. And it has a y value of 0. So if they ever ask you for an x-intercept, you know you can plug in a y value of 0. This is also an x-intercept. So an x-intercept on the other side. Now, this distance right here from the middle to that x-intercept is equal to this. Square root of b squared minus 4ac all over 2a. Now, this distance from here to here is also the same as that thing. But notice that I'm emphasizing it's the distance. Now, I hope that you are starting to put together a few things, noticing this and noticing this. What happens if you take the middle of the parabola and you add that distance? Wouldn't you go from the middle and go up to this one? But what if you took the middle and you went down? In other words, you subtracted that amount. I hope that you're starting to get the picture that if you want an x-intercept from a parabolic equation, that you can use this, the opposite of b over 2a, plus and minus square root of b squared minus 4ac all over 2a. Right? That's the middle. And you add it to find the one on the right, and you subtract it to find the one on the left. But you never see it written that way, do you? You always see it written like this. Oh yeah, the quadratic formula, right. It's really those two pieces. It's the middle, and then you're adding or subtracting a distance to go from the middle to those x-intercepts. But you may or may not have thought of it like that. That's really what, it's got a common denominator, so we add them together. So that's really what we're getting at. So the quadratic formula, okay, not just a cologne for men, helps us find x-intercepts. Sorry, I'm swatting at a fly. It's kind of annoying right now. Example 1 in the book says this. You've got this function, y equals 2x squared minus... Man, that fly is annoying. So there's the equation, and they say find... Whoa, did you see it? I think it just flew on screen. It went right under the camera. Okay? There it went again. My goodness. It's ridiculous. So one part of A says find x and y intercepts. That's not too hard, right? Plug a 0 in for x. What does that find? That finds y intercepts. If I plug a 0 in for x, 2 times 0 is 0 squared is 0. 0 times 2 is 0. Minus 3 times 0, 0, 0. Oh, it's this thing at the end. So when it's written in standard form, right? When you see it in standard form like that, ho ho, look at that. Right down here on the end is the y-intercept. Okay, that's what we call the y-intercept. Now that's only if it's in standard form. If you see it in Vertex form, don't try that trick at home or anywhere else, because now it's always true that you can plug 0 in for x. So that should always work. And if you're at all in question, just plug 0 in for x and you'll find it. Obviously plugging in 0 for y is going to find the x-intercepts. And when we do that, that's when we need the quadratic formula, okay, to find the other values. So I'm hoping you can do that. The opposite of -3 plus or minus the square root of -3 squared minus 4 times 2 times -2 all over 2 times 2. All right, so you're just following the formula, plugging in all the stuff that you need to. So we get 3 plus or minus, let's see, that's 9 plus, right, because you got 2 negatives right there that cancel out, so that's 16. 9 plus 16 is 25. Oh, look, a perfect square. So we have 3 plus 5. 3 plus 5 over 4. And 3 minus 5 over 4. Okay, that's going to give us 8 over 4, which is 2. And -2 over 4, which is -1/2. So those are my x-intercepts. Now I hope everybody remembers from last year that there are really 3 different situations. We can have a parabola do one of 3 things. Now obviously I chose all of these to be opening up, but you could choose them to open down too. But a parabola can never hit the y-axis, so no real solutions. A parabola can have 2 real solutions. Remember, real solutions mean it touches the x-axis. This has 1 real solution, and where is it touching? Right at the vertex, right there. Okay? Now the part under the radical, b squared minus 4ac, has a really cool name. It's called the discriminant. Okay? Discriminant. Not the stuff that you put in the washing machine, with the clothes. Okay, that's something completely different. I know some of you get that confused. But that's all right. That's all right. That's why we're in school. The discriminant will be equal to 0 in this case. I'm just going to put, the value of the discriminant. I'll use a D just so that we don't get confused and I'll have to write the whole thing out. If the discriminant is positive, you get 2 real solutions, and if the discriminant is negative, you have no real solutions. Now that does mean 2 complex solutions, and that would be, your imaginary numbers that we talked about last year, which you're all cringing right now about. But don't worry, you'll see them. Okay, tell whether the parabola has a maximum or a minimum point and find its coordinates. All right, so the same picture, we're dealing with that same equation from example 1. And I see that it opens up because it's got a positive a value, right? So if this is true, your a, your b, your c, if a is 0, then it opens up. And if a is less than 0, it opens down. Clearly in this example, we're dealing with that situation right there. So it's opening up, therefore it has a minimum at the vertex. Right? Just think about what an up-opening parabola looks like. I've drawn several so far in the notes. The fly is going to drive me insane. Okay. It really acts like it has a death wish, but I hope that it's going to go away now. It won't be my luck. Anyway, So we've got this parabola opening up. We're trying to find the vertex. Obviously, the vertex happens. Take a look at my picture here. Go back to the original picture. The vertex. It goes through this. The axis of symmetry goes right through that vertex. So the x value for the vertex will be the opposite of b over 2a. Now, how do you think I find the y value that goes with it? You're right. I plug it into the equation. So the axis of symmetry for my equation, let's see here, for this is x equals the opposite of negative 3 over 2 times 2. That's 3 over 4. So that would be called the axis of symmetry. And we're going to use that to find the value now. You know, and I know, that we can type 2x squared minus 3x minus 2, and we can find this value. So let's go to the graph. I'm not sure what the graph looks like. I might have a weird looking picture, so instead of trying to use this particular looking picture, I'm going to change it back to the standard window. Remember Zoom 6? Zoom 6 will cause me to get a basic looking picture, and if I need to go farther, I will. Now I'm going to use the trace button. And no, I'm not going to use the cursor to go over until I find the lowest point. And some of you are probably saying, well, why don't you use that, go to Second Calc and use the minimum feature? That is another way to do this. But I really need you to understand that you really can type in the opposite of b over 2a, and it will go to the bottom for me. It'll find that coordinate and list it for me. So I know that the minimum value is negative 3.125. So this is the vertex right here. So the vertex of this is 0.75, negative 3.125. 0.125 is 1/8 for those of you who were wondering, so you could use that fun fact at parties. I know there's a lot in this particular section, so I may only have you do half. We'll see. So here is an example of a quadratic model that I will explain to you. And I know at first it's going to look ugly, and you're like, what the heck is he writing? Okay? This is just an example of a quadratic function. If you've ever been in physics, you might have seen this already. All right? So the two variables that we have here are t, which is time in seconds, and h, which is the height above the ground. Or it could be above the water, or, just depends on where your starting point is. So those are your two variables. Everything else that you see in this equation, h sub 0, v sub 0, and g, those are all different numbers. So let's talk about what they are. G is your gravity constant. And that could be either 32 if we're talking about feet per second, or feet. If you're dealing in feet, obviously the units are feet per second squared because it's acceleration. We are going to use 9.8 if it's meters per second squared. Now, nobody's going to tell you these two numbers on a quiz or test. You're going to have to know these. So when you look at the problem, if it's in feet, you have one. If it's in meters, you have the other. Now, what was the other thing I was going to do? Oh, v sub 0. V sub 0 means original velocity. Now, I want you to ask me in class about the 3 different types of original velocity. 3 different types of original velocity. I'm going to give you specific words that are going to tell you which type it is, okay? But ask me in class about the 3 specific types of original velocity, okay? I mean, I know it, so ask me about that in class, and we'll put that in your notes. And we'll leave some space so you can put that in there. And then h sub 0 is the original height. The original height. And that may be in feet or meters, but obviously you'll be told that in a problem. So when we start out a problem, such as, let's say example 2. Example 2 says, suppose a ball is thrown upward from a height of 15 meters with an initial velocity of 20 meters per second. Okay? So, let's see if I can get this on screen. For you to take a look at. So when I look at the problem, it's thrown upward, okay, from a height of, so right here is my original height. I also notice that I'm dealing in meters, so that tells me my gravity constant is going to be 9.8. I know physics people that you guys use 9.81. We're just going to use 9.8, okay? With an initial velocity of 20 meters per second, okay? So they're telling me that the v sub 0 is 20. The h sub 0 is 15. By the fact that they threw it upward, that tells me that it's positive, and that actually gives you one of the specific types. Throwing something upward, it's positive, okay? A positive v sub 0. All right? So, oh, by the way, if you forget this little negative, the object will never come down. So that's kind of a critical negative right there. Otherwise, the object just continues into space forever and ever and ever, and you can't figure out why in the world the problem on the test isn't working. Okay. Since we were dealing in meters, this would be 9.8 t squared plus, right, there's the upward part, 20 t plus 15, and that's your original velocity and your original height. So if you simplified it, you get negative 4.9 t squared plus 20t plus 15. And in part A, they ask me a question. It says find, well, they just asked me to write the equation. So this really is part A right there. And part B, how high is the ball after 3 seconds? So how high is the ball after 3 seconds? So they gave me a t value of 3 and said, what is h? Okay? Well, you know, that can't be too terribly difficult. We're going to go back to the y equals in our calculator. Let's see what our equation is. Negative 4.9 x squared plus 20x plus 15. Okay, so here's my equation. Keep in mind that if you try to graph this on your standard window, you're going to be looking at it going, I don't get what's going on here. Well, let's just think about it. What's the lowest amount of time we should give it, since x represents my time? Well, let's go with 0 seconds to start with, because that's when the clock starts. Okay? And the object is not going to be driven into the ground, so negative, having a negative 10 doesn't really make any sense for this. But I know it goes upwards, and it starts out at 15 feet, so I'm going to try 20. Okay? I'll take a look at my graph. It looks like it goes up, and then it comes back down. I can shorten my graph on this side, but I really need to make it taller on this. Oops, I better expand out so you can see what I'm looking at. You're probably going, crazy idiot, what is he doing? I need to narrow this window down this way, and I need to raise it up on the top. So let's go back to my window, and I can go in maybe to 6, and I need to go up to 30. Okay? And it still looks like I haven't made my window tall enough. So maybe I go to 50. Okay? And now I have a good looking picture of the parabola, right? Because the object is going up and coming back down. Now keep in mind, this is not necessarily the flight path of the object. I know that if you throw an object, it will have a parabolic shape in the air. But you could throw this object straight up. You are measuring time as your independent variable and height as your dependent variable. It has nothing to do with horizontal and vertical distance. It's time and vertical distance. Okay? So maybe I should, I don't know. Height, hopefully you understand, is vertical distance. Well, in this particular example, remember, we've got our equation. I'm going to hit the trace button, and it's a good idea right now. Why? 3's already in the equation. Well, so I would type 3 and then hit enter, and it tells me that the height above the ground is 30.9. And, if you needed 4, you could tell it that, and it would go find it for you. But we wanted 3, 30.9. Okay? Or you can go through and plug it in. You can do it on the home screen. Quit. Negative 4.9 times 3 squared plus 20 times 3 plus 15. And you can get the same thing by doing it on the home screen using 3 for both of the t's. And because I've already gone 20 minutes, I'm going to stop right there. We'll talk about the rest of it in class.